Okay, eighth graders, welcome to Redzone number one. They're called red zones because we are near to the end zone, to the goal line. We're near to the finish. So what each red zone is going to do is to review a different topic that we've learned this year. We're focusing on the major topics and also the topics that you are most likely to see again in ninth grade algebra, which at this point is a big deal because we're doing homeschool right now, but you are going to be back in school next year. So we want to make sure you're ready. So the first red zone is all about solving equations. Solving equations has been coming up all year. It's part of almost every topic we do, but let's just remind ourselves the steps for solving an equation. So here's a sample equation that I made up here, and these are the steps you're going to follow. Now, you don't always have to follow these steps in this exact order. There are many ways to solve equations. Sometimes it's best to, if you can, look at the equation, think ahead, think what the next step's going to be, and try to make your life easier. But I know a lot of you like having a procedure to follow, and as you get better at that procedure, it just becomes more natural. So for those people, this is the procedure that I think all of the eighth grade teachers this year usually follow. So step one, use the distributive property. Now I wrote when possible, because not every question is going to have the distributive property. This one does, because I noticed there's parentheses with multiple terms in it, and there's a coefficient of 3 in front of the parentheses. So when there's a number in front of the parentheses like this, you need to distribute it by drawing those arrows into the parentheses, and that means we're going to be using multiplication. So I'm going to pull up a red pen. I'm going to try to keep everything color-coded, and I'm going to use the distributive property. So when I draw these arrows, that reminds me I'm multiplying. 3 times 2x is 6x. And then 3 times positive 1 is positive 3, so I write plus 3. The two biggest mistakes that you get with the distributive property are that you don't multiply to both terms. You only multiply the 3 times the 2x, and you end up writing plus 1. And the other mistake has to do with positives and negatives. This one doesn't matter because everything is positive. But if this was a negative 3 in front, then you would have to make everything negative. If this was a negative 3 and this was minus 1, then you have to think about what a negative times a negative is. Never write this plus sign, the one that's inside the parentheses. Don't write it until you do the multiplication. Then if it comes out positive, put plus, and if it comes out negative, put minus. I'm just going to rewrite the other side. You can simplify it now, but I'm going to do it one step at a time just to show you guys. So I'm just rewriting it. So if solving equations isn't your strongest thing, it's best to just do one step at a time and then rewrite it right underneath the first one. So you could see exactly what you did. Everything's nice and neat. That equal sign ends up in the same spot. All right, so step 2, and you can see I wrote it in blue over here, is combine like terms. Now, that also is not always possible. Not every equation has combining like terms. When we say combining like terms, we are talking about adding and subtracting terms that are alike, terms that have the same variable or terms that are both constants. They have to be on the same side of the equation. I know a lot of 7th graders came into 8th grade with this cool idea of drawing like a bridge down the middle of your equation, and that separates the equation into two sides. So that's kind of what I'm talking about here. When we're combining like terms, you can see that there's an x and a 4x on the right side of the equation. On the left side, there are no like terms. Those are two unlike terms, and you can't actually add them together. We'll talk more about that bridge in a second, but let me get rid of it. So we have an x and a 4x. I'm going to add those together because that's combining like terms. 6x plus 3 equals x plus 4x is 5x plus 5. Again, I do one thing at a time. I rewrite it directly under where I was just working, so it's nice and neat, and I can see what I did. That brings us to step 3. If there are variables on both sides of the equation, you need to bring them together. Well, I do see some variables on both sides of the equation. I see there's a 6x on this side, a 5x on this side. And as I was just talking about, if you draw that bridge, if you need to bring something from one side of the equation to the other, if you need to cross over the bridge, you need to do inverse operations. And whatever you do to one side, you have to do to the other. So if I want to bring that 5x from one side of the equation to the other, I need to do minus 5x, because that'll cancel it out, because 5x minus 5x is 0. But I have to keep the equation balanced. So whatever I do to one side, I have to do to the other. 6x minus 5x is 1x, but I don't need to write 1x. I can just write x, and then plus 3 equals 5. Bring everything down right underneath where I just wrote it. And now most of you see this and probably know what to do. Now it's either a one-step or a two-step equation. But for those who don't remember, step 4, bring the constants to the other side of the equation. So whichever side you brought the variable to, you need to bring the constant to the other side, because you're trying to isolate the variable. You're trying to get the x on one side, in this case the left side, and you're trying to get all the numbers on the other side, in this case the right side. When you move the variables like I did in the previous step, in the green step, notice that I chose to move the 5x. It's usually easier if you move the smaller variable. Now there are going to be some equations where it's not easier to do that, but in this case it is, because then you don't have to deal with negative variables. Okay, so now I moved all the variables to the left and I got x, so I need to move the 3 to the other side, but whenever I cross over, whenever I go from one side of the equation to the other, I need to do inverse operations, because 3 minus 3 is 0. Balance method, do the same thing to both sides, and I get x equals 2. And that's the answer to this equation. That's the solution. What does it mean to be a solution? Remember that the solution to the equation is the only number you can substitute in to make both sides of the equation the same. So if I take this 2 and I plug it into the original equation anywhere I see an x, and then I simplify it, both sides of the equation will come out equal, which they should, because there's an equal sign in the middle. But if you remember from Unit 1, a long time ago, some equations have no solution, meaning there is no number that'll make the two sides equal. And some equations have infinitely many solutions, meaning any number will make the two sides equal. Let's take a look at 2 of those. So notice this equation right here, 3x plus 5 equals 3x plus 8. There is no distributive property, there's no combining like terms, so I'm just going straight to solving it. There's variables on both sides. I need to get them on the same side. Some of you right now are probably thinking we don't even need to do that. I'll get to that in a second. But if I want to get them on the same side, let's say I wanted to move this 3x to the left side, I would need to do minus 3x, the inverse. That crosses it out. I do it over here, but when that happens, that crosses out as well. And I get 5 equals 8, but that doesn't make sense because the number 5 does not equal the number 8. So this is not true, meaning there's no solution. So anytime you end up with two numbers that are not actually equal to each other, there's no solution. Even if one of those numbers is a 0, that confuses people sometimes. I'm going to rewrite the original for a second. We learned back in Unit 1 that when you get to this step, you can actually just stop. Because no matter what number I plug into where the x is, they're never going to be equal. Because if I take that number and I multiply it by 3, and on one side I add 5, and on the other side I add 8, there is no way those two sides can ever come out equal. Same idea in this other one. We learned in Unit 1 that you can stop here, because no matter what number you plug into the x, you're doing the same exact thing on both sides. You're multiplying it by 2, and then you're adding 1. So I can pick any number that exists, plug it in, multiply it by 2, and add 1, and it's going to be exactly the same on both sides. But just to show you, let's actually solve it. So I do minus 2x from both sides, and I get 1 equals 1. Well, that is true. That's always true. So this is an equation that has infinitely many solutions. And if you remember, this concept of no solution and infinitely many came up again when we did systems of equations, and it's going to come up again in 9th grade. So you do need to know it. All right, so in this slide, there are some practice equations. So I'm going to pause the video. I'm going to put up the work and all the answers, and you're just going to self-assess. So you should pause the video at this point and only unpause it when you are ready to check all of your answers. I'm going to go over number 3 slowly. So when you get up to that one, if you want to watch the video, you can. and then you can use that to help you with number 4. So in about 5 seconds, all the answers are going to pop up, so pause the video. Okay, the answers to the first 2 questions are up. You can see in the first one I did the distributive property, and when I did, you can already see right here at this step, both sides are 12x minus 8. So I could have stopped there and just stated that there were infinitely many solutions. I took it one step further. I subtracted 12x from both sides, and then I see that negative 8 equals negative 8, which is, no matter what, always going to be true. The second one, I didn't have to do distributive property, combining like terms, anything like that. All I needed to do was get the variables on the same side. So I chose to do minus x to move this variable from the right side of the equation to the left. The reason I chose that was twofold. The first one, that's the smaller variable, so I knew that would make my life easier. But also, if you look at the left side of the equation, there's nothing there except a variable. So that has to be the side that we need to bring all the variables over to. I need to bring all the variables here. And when I did that, it came out really easily to x equals 1. So now let's take a look at the third one. 3x plus 4 equals 3x. Some of you are looking at this and probably like, I already know the answer. But if you're not, and you're in that, I need to solve this equation mindset, then let's go through it. I notice there's a variable on both sides. There's a 3x on this side, a 3x on this side. If you're someone who draws the bridge, draw the bridge. But since there's variables on both sides, I need to get them together by doing inverse operations. The inverse of positive 3x is minus 3x. So I do that to both sides, but it cancels out on both sides. Now, a lot of students are just going to write down 4, and that's it, because there's nothing else. But then they do this thing where they write x equals 4, and that doesn't make sense. You can never get rid of the equal sign. So if you look at this, 3x minus 3x has a value. We usually just don't have to write it. But since there's nothing there, there's nothing left here, you need to write a 0. 4 equals 0 doesn't make sense. There's no solution. And the last one is the same idea. 15x minus 15x on both sides. You get 10 equals 0. Also, no solution. But you could have noticed right from the beginning that there's a 15x on both sides, and this side has a plus 10, and this side has nothing. So there's definitely not going to be a solution. All right, here's 3 more practice problems. So same idea. Pause the video, and in about 5 seconds, the answers and the work are going to be up on the screen. All right, check your work, check your answers. If you want to pause the video to check it, that's a good idea. Otherwise, I'm just going to talk through each of them really quickly. The first one, the blue one, I did the distributive property on both sides. You can do that right at the same time if you want, since it's the same idea on both sides. The left side came out to 18 minus 12x. Be careful with your signs. The right side, you have to be really careful, came out to negative 12x plus 18, because negative 2 times negative 9 is plus 18. If you're someone who's paying attention, you could stop there. There's a negative 12x on both sides, and then positive 18 on both sides, infinitely many solutions. If you're not, you can do plus 12x to both sides, which is perfectly fine. And if you do that, it cancels out on both sides, and you get 18 equals 18. Second one in red, you do the distributive property. Then it's just a 2-step equation. You add 5 to both sides and divide by 2. You get 22.5. You could leave your answer as 45 over 2. That's fine. And in the purple one at the bottom, this one had an extra step. You needed to do distributive property on both sides. But then on the right side, there were like terms. The 10x and the minus 4x were like terms. So then you have 6x plus 10 on the left, 6x minus 20 on the right. And when you notice that they have the same variable but different constants, that means there's going to be no solution. So no solution on that one. No number you can plug in to make the 2 sides equal. At this point, just keep pausing the video, keep doing the practice problems, and I'm going to keep putting up the work and the answers. If you have questions about it, this is where you should reach out to your teachers, tell them you don't understand, see if there's more videos or more resources that you can do, or maybe you can go on a live Google Meet session with them. But I'm going to go through the rest of the packet pretty quickly now because it's mostly just practice problems at this point. All right, so pause the video, do these questions, unpause, check your answer. All right, so the first one, once you do the distributive property, you notice that both sides have a 3x, but they have different constants. One side has a minus 12, one side has a plus 7, no solution. The second one, pretty straightforward, distributive property, then it's a two-step equation. This is a 7th grade problem that you just happen to see again in 8th grade, and the same way you're going to see it again in 9th grade algebra. Solve it, 3/4 times 8x, 3/4 times negative 12, then you add the constant, divide by 6, and you get 5.5. If you're getting an answer that isn't there, let's say you made a mistake somewhere and you got like x equals negative 3.5. Don't just pick no solution because you got it wrong. Go back and look for your mistake. All right, so Anna says that the only first step to solve the following equation is to start by doing the distributive property. Ben says that there are multiple first steps. Who is correct? Why? Write down an answer. Practice writing your answers. One of the things that 8th graders tend to be the worst at is explaining their answers. Not just showing their work, not saying, I did plus 5, I did divided by this, but explaining why you know something. So try it here, then unpause the video, and I'll have my answer up and we'll talk about it. All right, so my answers are at the bottom. If you want to pause it and read it, you can. Otherwise, I'm just going to talk about this question. Ben's correct. You can do the distributive property first, like Anna said. There's nothing wrong with that, and that's exactly how I would probably do it. I think almost every 8th grade teacher would do it that way, and almost every 8th grade student would do it that way. But that's not the only first step you can make. You could subtract 6 from both sides. You're going to end up doing something like that anyway, so you could start by doing that. You could add 9 to both sides. You could do that. You could take this 3 and instead of multiplying it, get rid of it another way by dividing every term by 3. You could start by doing that. There's a million steps, not a million, but there's a bunch of steps you could do first. So Ben is correct. There are other ways to solve the equation, and that's kind of the point we want you to understand moving forward. There's a lot of different ways to solve equations, and there's a lot of topics that are going to be coming up in high school math where you need to decide when it's appropriate to do what. If you think about when we did systems of equations and we learned 3 methods, graphing, substitution, elimination, a big part of that unit was deciding when to use each method, when each method would be best. And it's the same thing when you're solving an equation. Is it best here to do distributive property? Is it best to minus 6? That's what you need to decide. All right, here's another practice problem. A lot of these questions probably look familiar. We pulled these straight out of your old unit test, out of old state exams. Pause the video, do it, unpause it, check your work. All right, check your work. You got to do the distributive property twice. Double distributive property, that's something that comes up in algebra, so be on the lookout for that. Then you needed to combine like terms. This is where a lot of you made mistakes back in Unit 1. It's 9x plus 2x is 11x. Some of you choose to do inverse operations here, but if you're someone who draws the bridge or you separate the equation into 2 sides, all of this, 9x minus 15 plus 2x plus 14, is on the same side. So you just combine like terms. No need for inverse operations yet. Then the other mistake is this is a minus 15 and this is a plus 14. Minus 15 plus 14 is negative 1. That's where the minus 1 comes from. Then we do inverse operations. To add 1, we get 7, and then divide by 11 to get 7 over 11. Choice A. How many solutions, if any, does the equation have? Pause, do it, unpause, check. All right, so I did the first step. I distributed on both sides. And back in the state exam, you could stop here and write the answer. The answer is 1 because it says how many solutions. 1 solution, not what is the solution. You didn't need to actually solve it. If you want to continue, you can. Remember we said there's a lot of different ways you can do this. One would be to combine like terms. So then you'd have 10x minus 6 equals 3x minus 1. And again, you could stop there and just say there's 1 solution. Once there's different variables on both sides, 10x, 3x, you could stop and say 1 solution. Or we can get the variables together. You do minus 3x to both sides. So you get 7x minus 6 equals negative 1. Add 6 to both sides. 7x equals 5. Divide by 7. X equals 5 over 7. That's one way to do it. Another way to do it, if I go back to this first step, I notice there's a 3x on this side and a 3x on that side. So if you do minus 3x to both sides, they're going to cancel out. Maybe that'll make your life easier, because then you have negative 6 plus 7x equals negative 1, and that's just a two-step equation. And you get the same thing of 5 over 7. I'm not going to go through it. But either way, if you write this as your answer, that's not correct. You're only going to get 1 point. To get full credit, you have... Sorry, had to pause the video to kill a moth, but here we are. To get full credit, you had to write one solution. That's what the question was asking. All right, try to go ahead of me here. I'm going to do it out loud in about 5 seconds. Write it down. If you want to start, start. Otherwise, just follow along. Two-step equation. We're trying to isolate the variable. We start by doing minus 5 on both sides. 2/3 x equals negative 4. Now, there's a lot of different ways you can get rid of this fraction. If you have a good calculator, which you all do, or you can get one online, you can just divide both sides by 2/3. If you have the multi-view, the yellow one or the white and blue one we've been using all year, that's pretty easy to plug in. If you don't have a multi-view, that's not so easy to plug in. So that's one option. Another option is to multiply the fraction by its reciprocal, 3 over 2, because then you can cross-cancel everything out and do the same thing on this side. So you could do that. That's a little easier to do by hand. Or the way I like to do it, and this is a way that might help you in the future, anytime you want to start getting rid of a fraction, you can multiply by its denominator. So multiply both sides by 3. The 3's cancel out, and you're left with 2x equals negative 12. That's a lot easier to solve. X equals negative 6. So those are 3 ways you can get rid of a fraction. You get to choose whichever one seems best for you. All right, same thing here. Try to go ahead. I'm going to give it like 5 seconds, and I'm going to do it. All right, here we go. Distributive property, 5c plus 4 equals 2c minus 10. Variables on both sides. Probably easier to move the smaller variable to get rid of it. Do the inverse. Do the same thing to both sides. 3c plus 4 equals negative 10. Now bring the constant to the other side by doing minus 4. 3c equals negative 14. Divide both sides by 3. C equals negative 14 over 3. And if you convert that to a mixed number, it's choice A. All right, this one's a little different. It says, what value for the constant h in the equation shown below will result in an infinite number of solutions? I'm going to rewrite it so it's a little bigger. That gives me a little more room to work with it. So what the question's asking you is, what number can we replace that h with that'll make both sides have infinitely many solutions? Well, remember we talked about earlier, and at any point if you feel like I've said something to give you a hint or you're ready to go, pause the video, do the question. If you remember earlier, for an equation to have infinitely many solutions, both sides, the left side and the right side, have to be exactly the same. So basically what this question is asking is, what number can I put here that when I do the distributive property will give me 6x plus 18? And luckily for us, this is a multiple choice question. So you can just take a look at each choice and try them out. So let's try negative 2. 6x plus 18 equals negative 2 times 3x plus 9. Distribute that, and you get negative 6x minus 18. Well, close, but not exact, but that should give you an idea of what the actual answer is. So instead of trying negative 2, let's try positive 2. So I'm replacing the h with a positive 2, and then I'm distributing. 6x plus 18 equals 6x plus 18. Perfect. Choice C. All right, pause the video. Do your best on it. Decimals, fractions, use your calculator. It'll help you. And then unpause it and just check the work. All right, check your work here. Even I chose to pick up a calculator and use it. It made my life a lot easier. Distributive property on the right-hand side, then combine like terms on both sides. I chose, when I got to here, when I got to this step, I chose to do plus 10x to both sides because negative 10.5x is the smaller one, and I didn't want to deal with these negatives anymore. And when I added it to both sides, it made the equation pretty nice because it made it a positive 6x. And then it was a two-step equation, and it came out to negative 1/3, no problem there. If it comes out to a repeating decimal, write it as a fraction. All right, when you unpause the video, answer is going to be up. All right, distributed on both sides. Careful here when you do -2 times +3, you get a -6. And then careful when you combine your like terms, it's a 3t and a -4t. And the answer comes out to 10. Hopefully you remember this question. You guys did not like it when we did it, but it's not as bad as you're going to make it out to seem. This one I'll talk about first, then I'll pause it. I'm going to put all the work up. It says that side AB is congruent to DF. We know that congruent means equal to. This is side AB. I'm just connecting the side with those letters. This is side DF. It says they're congruent. That means they are equal. So I'm just taking this and setting it equal to that. Then the next sentence says that side BC is congruent to FG. So I'm going to take this and set it equal to that, completely separately, two separate equations. So now I'm going to write those equations and solve it. So pause the video, do it on your own, then unpause it. There you go. Pause it to check your work if you need to. I wrote both equations. I showed most of my work, so it should be straightforward. If not, reach out to your teachers. All right, I'm going to pause it now. Answer is going to be up in a few seconds. All I did in this one, combine like terms on both sides. They both come out to 3x plus 11, so there are infinitely many solutions. This is a two-step equation involving a fraction. Your favorite, add 2 to both sides. You get 3/4 p equals -21. And then figure out how to solve this any way you want. Divide by 3/4, multiply by the reciprocal, 4/3, or just multiply by the denominator and do it in two separate steps. So if I multiply both sides by 4, I get 3p equals -84. And divide both sides by 3, and I get p equals -28, choice C. Here we go. If you want to split the equation up into two sides, that'll make it a little easier of what you're going to do, because we still get to this point where students see this, and because this variable and this one are separated by something in between them, students tend to do inverse operations, but this is not an inverse operation question. This is a combining like terms question. -2.1k plus 6.5k is 4.4k plus 13 equals 24. 4.4k equals 11. K equals probably 2.5 looking at those choices. All right, distribute on both sides. You should be pausing it, doing it, then unpausing it. But here we go. -6x minus 3 plus 3x equals 6x plus 3. Then I can combine like terms. -3x minus 3 equals 6x plus 3. Move the smaller variable. -3 equals 9x plus 3. Move the constants to the other side. 9x equals -6. Divide by 9, x equals -2/3. Choice B. All right, here's 5 equations from your Unit 1 exam. You need to solve each one and then write down how many solutions there are. So I'm going to pause it, put up all the work, and then write the answers. All right, so the answers are no solution, infinitely many, no solution, and one solution. The hardest part about this was that in number 2 and 3, each side of the equation was written in a different order, so maybe you don't recognize that it's infinitely many. And in number 4, they made it a little tricky with this distributive property with the 3x plus x in the parentheses, but combining like terms in distributive property, it came out to 12x. All right, so that's it. That was a long video. I think we're going to split this up into 2 assignments. But if you have any questions still in solving equations, you need to be doing extra practice. You can't just go, 8th grade's over, I'm done with this. 9th grade algebra, 10th grade geometry, 11th grade algebra 2 trig, chemistry, physics, any kind of technology class you take, you're going to have to solve equations. You're not going to escape it. So it's better to figure it out now while we have this time than later. So reach out to your teachers, look up videos on Google and YouTube, and ask for help when you need it.